In this series of videos I want to talk about some problems related to rectangular and trapezoidal approximation, and these are all free response questions from the AP tests. This first one comes from 1996, and it's hard to tell looking back now whether that was a calculator problem or a non-calculator or a four-function calculator or rather scientific calculator problem. I don't believe it was a graphing calculator problem at that particular point, but it certainly might have been a scientific calculator problem. Let's take a look at it. We have capital F of x is equal to the integral from 0 to x of sine of quantity t squared dt for x greater than or equal to 0, less than or equal to 3. A. Use the trapezoidal rule with 4 equal subdivisions on the closed interval from 0 to 1 to approximate f of 1. And the first thing that I want to do is to set up my 4 subdivisions of equal width going from 0 to 1, and so I can see that each of those subdivisions is going to become one trapezoidal area, and the bases are going to be the vertical lines. The height is going to be the perpendicular distance between the perpendicular lines. So in this case h is equal to 1/4. Now I need to add up all of those rectangular areas, and each of them is going to be h over 2 times the sum of the pair of bases. So h over 2 is going to be 1/8. So for the first, I need the sum of the two bases. Then for the second, I'm going to take the sum of the two bases for that, etc. Now the first base, or for the first trapezoidal area, the two bases will be sine of 0 and sine of 1/16, since 1/4 squared is 1/16. Then for the second trapezoidal area, the two bases will be sine of 1/16 and sine of 1/4. Now for the third trapezoidal area, the two bases will be sine of 1/4 and sine of 9/16. And so you might notice that each of aside from the first and the last, each of those bases are being counted twice, because sine of 1/16 is the right base for the first trapezoidal area, but it's also the left base for the second trapezoidal area. And so finally the last base will be sine of 1. And so now we just need to put them all together, remembering that each one will be counted twice except for the first and the last one. And we're going to factor out the 1/8, that is the h over 2 times the sum of the bases, which happens in each of those 4 trapezoidal areas. So we get capital F of 1 is approximately equal to 1/8 times the quantity, sine of 0, which happens to be 0, so we don't even need to count that, then 2 times sine of 1/16. Again, once because it's the right base of the first trapezoidal area, and the second time because it's the left base of the second trapezoidal area. Then we have 2 times sine of 1/4, 2 times sine of 9/16, and finally 1 times sine of 1. And so in the event this was a non-calculator question, then that would be sufficient for the answer. You can obviously just plug this into your calculator and get a result for that. And so you can see that's what I've done. 1/8 is 0.125 times 2 times the quantity, 2 sine of 1/16 plus 2 sine of 1/4 plus 2 sine of 9/16 plus sine of 1, and that's roughly equal to 0.316. Okay, we'll close down the calculator and go on to the next question. Part B, on what intervals is f increasing? Now we simply state that f increases when f prime of x is positive. F prime of x, the derivative of f of x, is equal to sine of x squared by the second part of the fundamental theorem of calculus. Then f prime of x will be positive when x squared is between 0 and pi, and we may need to go beyond that since we're on the interval from 0 to 3. So it might also be when x squared is between 2 pi and 3 pi. If we take the square of all those sides, then f prime will be positive when x is between 0 and square root of pi, or when x is between square root of 2 pi and 3. 2 pi is roughly 6, so the square root of that is still less than 3, but square root of 3 pi will be 9 times will be square root of a little bit more than 9, so that will be beyond 3. So we only